Hello, my name is Larissa. I am an MIT undergrad, and this lesson will describe isotopes and relative atomic mass. First, relative atomic mass is referred to as such because it is equal to 1/12 the mass of a carbon-12 atom. A carbon-12 atom has 6 neutrons and 6 protons. One of the reasons for the use of carbon-12 as our standard of measure is that its mass is easy to measure relative to other elements because it does not decay as quickly, so the mass will not change an appreciable amount during the measurement. This gives a neutron and a proton each a relative atomic mass of 1 AMU. The conversion of these masses into a unit called atomic mass units enables us to work with a unit of measure that is more closely related to what we're working with. The reason this is so useful is because one atomic mass unit is so small that it's very useful to have a new unit of measure to describe these atomic masses. They're very, very small when compared to a gram. 1.660,540 times 10 to the negative 24th grams, which is very small. An isotope is an atom of the same element so it has the same atomic number and the same number of protons, but it differs in its number of neutrons, and therefore its atomic mass, because the neutrons are contributing to the atomic mass, so a variance in the number of neutrons means that this atom has a different atomic mass from an atom of the same element with a different number of neutrons. These two would be referred to as isotopes. A helpful example of this is the isotopes of hydrogen. They have names. Protium, deuterium, and tritium all have an atomic number of 1. Each isotope has the same atomic number and the same number of protons, which is 1. However, they vary in their numbers of neutrons, which are respectively 0, 1, and 2, resulting in a total mass, so an atomic mass, of 1, 2, and 3 respectively. So, to calculate the atomic mass, protium is atomic number 1, so 1 proton, no neutrons, atomic mass of 1. You sum the atomic number and the number of neutrons for deuterium and get 2. Likewise, tritium results in 3. The presence of isotopes is well documented on the periodic table. When you look at the mass number for hydrogen, you may be surprised to see that it's equal to 1.008. How is this possible if hydrogen only has 1 proton? Wouldn't the mass be 1 atomic unit? Not quite. This is due to the presence of hydrogen's isotopes in nature. Protium The most common form of hydrogen, as we already know, has an atomic mass of 1, deuterium 2 and tritium 3. Now, deuterium and tritium are so rare that they occur very infrequently in nature. Protium, however, is very bountiful. So, when we calculate the average atomic mass of the element hydrogen, we'll see that 99.9885% is indeed hydrogen 1, protium, with a mass number of 1. And you will see that 0.0115% is hydrogen 2, which is deuterium, so hydrogen with a mass of 2. And this is where we get 1.008. Now, the actual values for the atomic mass are indeed slightly different. This actually is closer to 1.007825, and this is actually closer to 2.014102 atomic mass units. But the average atomic mass of the element hydrogen is indeed 1.008 in nature.